Look up at the night sky. What do you see? Is it just darkness or is there something more? A sea of twinkling stars, right? Each one shimmering like a distant diamond. Each one a tiny point of light, millions of miles away, yet so bright and clear. But they're more than just pretty lights. Stars are storytellers, ancient and wise. They whisper tales of the universe, its birth, its life, and its future. These celestial bodies hold secrets of time and space. For centuries, humans have looked to the stars with wonder, seeking answers and inspiration. We've created constellations, weaving stories into their patterns, connecting the dots in the sky. We've used them to navigate, to tell time, and to understand our place in the cosmos. They have been our guides and our clocks. But what are these celestial storytellers? What mysteries do they hold? Where do they come from? How do they begin their luminous journey? And what happens to them when their light fades away? Do they simply vanish or do they transform? The answers lie in the heart of astrophysics, in the fiery birth, the long lives, and the dramatic deaths of stars. It's a cycle of creation and destruction. Let's embark on a journey to unravel their secrets. Together we'll explore the wonders of the universe, one star at a time. Stars are born in cosmic clouds of gas and dust called nebulae. These nebulae, vast and cold, are like giant stellar nurseries. Gravity is the midwife, gently pulling the gas and dust together. As more and more material clumps together, the center of the cloud gets denser and hotter. The heat and pressure become so intense that hydrogen atoms, the simplest elements, begin to fuse. This fusion is the spark of life for a star. The fusion process releases enormous amounts of energy, mostly in the form of light and heat. This is what makes stars shine. The newborn star pushes back against the collapsing cloud, eventually reaching a state of equilibrium. A star is born. A star's life is a constant battle against gravity, a force that never relents. The outward pressure from fusion tries to push the star apart, creating a delicate balance, while gravity tries to pull it all back in, striving to collapse the star into itself. The star's mass determines who wins this cosmic tug-of-war and how long the star will live. Massive stars and smaller stars have very different fates. Smaller stars, like our sun, are like the marathon runners of the cosmos, enduring for eons. They burn their fuel slowly and steadily, shining for billions of years, providing a stable source of light and heat. These stars are the cosmic factories of the universe, creating heavier elements like carbon, oxygen, and nitrogen in their cores, essential for life as we know it. Larger stars, however, are like the sprinters, burning with intense energy. They are much brighter and hotter, but they burn through their fuel much faster, living shorter, more dramatic lives. These stars live for only millions of years, but they play a crucial role in creating the heaviest elements in the universe, such as gold and uranium, through their explosive deaths. Section 4. The grand finale, supernovae, neutron stars, and black holes. This is where the life cycle of a star reaches its most dramatic and awe-inspiring conclusion. When a star runs out of fuel, the outward pressure from fusion stops. This marks the beginning of the end for the star. Gravity, the ultimate victor, takes over. With nothing to counteract it, the star begins to collapse under its own weight. The star's core collapses in on itself, triggering a catastrophic explosion known as a supernova. This explosion is so powerful that it can briefly outshine an entire galaxy. Supernovae are some of the most brilliant events in the universe. They light up the cosmos with their incredible energy. For a brief time, they can outshine an entire galaxy. Imagine the energy required to outshine billions of stars. These explosions scatter the elements forged in the star's core throughout space, seeding the universe with the building blocks of planets and even life itself. This cosmic debris is essential for the formation of new stars and planetary systems. What remains after a supernova depends on the mass of the original star. The remnants can vary dramatically. Smaller stars leave behind dense spinning remnants called neutron stars. These stars are incredibly fascinating objects. These bizarre objects are incredibly dense. Imagine squeezing the mass of our sun into something the size of a city. The density is so extreme that a sugar cube-sized amount of neutron star material would weigh about 1 billion tons on Earth. The most massive stars, however, collapse into objects so dense that not even light can escape their gravitational pull. These are the enigmatic black holes. We call these mysterious objects black holes. They are the ultimate end state of massive stars, and their gravitational pull is so strong that they warp the very fabric of space and time around them. Section 5. Cosmic alchemy stars as the universe's element factories. Remember those heavier elements we talked about, the ones like carbon and oxygen? Well, they're not just important for planets and life, they're essential for the universe as we know it. Stars are the only places where these elements can be created. The intense heat and pressure in their cores act like giant cosmic furnaces, fusing lighter elements into heavier ones. When stars die, especially in supernova explosions, they scatter these newly formed elements into space. This cosmic recycling is what allows for the formation of new stars, planets, and even life. We are, quite literally, made from stardust. Section 6. The uncharted cosmos. Mysteries amidst the stars. Even though we've learned so much about stars, the universe still holds many secrets. We don't fully understand how black holes work, or what happens at their very center. We're still searching for answers about dark matter and dark energy, mysterious forces that seem to be shaping the universe. And we continue to explore the possibility of life beyond Earth, perhaps on planets orbiting other stars. The stars have been our companions and guides for millennia. They've inspired our myths, our science, and our imaginations. As we continue to explore the cosmos, we can be sure that these celestial storytellers will continue to amaze us with their beauty, their power, and their enduring mysteries.